Okay, in this example, I'm going to show how we use a motor driver or motor controller chip to control a DC motor. You'll notice that with this chip, you're going to give power in a few locations. We need to remember that we're going to get power and ground from our Arduino. I'm going to jump power to both sides of my breadboard. And I'm going to make sure I have ground on the top and bottom terminals as well. You'll see that this ground wires 2 on the top, 2 on the bottom. And then on this chip, essentially there's 2 sides. I have input and output 4, input and output 3, and then I have input and output 1 and 2 on the bottom half. So essentially, there's enable 1 and 2, and then there's also enable 3 and 4. I'm only going to use the bottom half of my chip because I'm only going to be driving one DC motor. If I was using multiple motors, I would also use that top half of that chip as well. So the enable, we're going to use one of our Arduino pins to control that. I'm going to leave that wire green. Then I'm going to have input 1, use pin 4 for input 1. And then I have input 2, orange, input 2. I'm going to hook that to pin 5. So I'm going to use pins 3, 4, and 5. So that sets it up. I have my output pins 1 and output pins 2, and those will be what I hook up to my DC motor. Drag my DC motor onto my board. The orientation of these 2 terminals doesn't really matter if I have it wired one way or the other. It just means that the motor will either spin in one way or the other based on what combination of inputs I give from the Arduino. So in this case, I'm just going to hook up output 1 to terminal 1. And again, you'll see once I've hooked them up, there's a red and a black, but again, that does not matter unless I want to be specific about the direction that it's going to be spinning. So my output 2 is going to go to my other motor pin. So I'm going to use different colors so you're able to trace that. So again, I have my output pin 1 to one of the terminals, and I have my output pin 2 to the other terminal of the DC motor. Now in the code, I need to make sure I'm setting up all 3 of these output pins. So in this case, I have pin 3 is going to be output. I'll label that the enable pin. So again, that either powers up or doesn't power up that chip to control the output to that DC motor. So I have pin 4. This is going to be my motor pin A. Pin 5 is also going to be output, and that's going to be my motor pin B. So again, my 2 input pins that I'm going to be using from the Arduino are going to control the direction of that motor, because the whole point of using this motor driver is to be able to control direction and speed. So in the most basic example, I'm basically going to spin it in one direction. I'm going to spin it the other direction, and then I'm going to stop it. So whenever I want the motor to be able to spin, I need to engage or turn on the enable pin. So in this case, I'm going to do a digital write, and that's going to be to pin 3. I'm going to set that to high. So my enable pin is on. Now to choose this direction, I'm going to write to pins 3 and 4. When I'm doing that, I need one of them to be high and one of them to be low. So if I set pin 4 to high, that means my motor enable pin A is high or on. I'm going to do a digital rate pin 5, that's going to be low. So again, whenever I'm writing to pin A and B, only one can be high at a time. So I'm going to turn one on and one off. So in this case, I have pin A on and I have pin B off. So if I just run that simulation, you can see that in fact my motor is spinning. The RPMs are labeled in here. You can see there's a negative, so that's just showing it's spinning, in this case, counterclockwise. So like I mentioned before, if I wanted it to spin in a certain orientation when A is high or B is low, I can just flip those two wires. But you can see when I set pin A to high and B, it spins the full RPMs, just over 9,000 RPMs, counterclockwise. Just going to set a little delay here so that I can see the changes as they happen. And then I'm going to repeat similar combination. So my first one, first of all, is spins counterclockwise. So again, if these were wheels on a car or something like that, you could have it as forward or reverse. And I'm going to try to get the motor to spin clockwise. So in this case, instead of having pin A on, I'm going to switch that to off. So I have to set pin 4 to low, and then motor pin B is going to be on. And so I'm going to set that to high. So I'm going to basically, in this case, when I run it, you'll see that it'll spin counterclockwise for 2 seconds, then it'll spin clockwise for 2 seconds, and then it'll repeat that. So if you keep an eye on the RPMs, you can see it's negative 9,000 RPMs, and then it goes to positive. So it goes back and forth spinning counterclockwise and then clockwise, so 2 seconds about. The other thing I want to show you is how I stop the motor. That enable pin is what gives the motor the power. So if I do a digital rate to pin 3 and change that low, it doesn't matter what the values are at pin A and pin B, because the motor is getting no power. So in this case, if I added that to the combination of rates, then I'm simply going to see it spin one direction for 2 seconds, and it's going to spin the other direction for 2 seconds, and it's going to stop for 2 seconds. So again, negative 9,000 RPMs, 9,000 RPMs, 0 RPMs. So you can see it's going counterclockwise for 2 seconds, clockwise for 2 seconds, and then stopping for 2 seconds. In terms of a functional step here, I probably wouldn't want my motor to be spinning full in one direction and then all of a sudden getting it to spin full in the other direction. So what I'm going to do is just add the sequence in between. So that it spins in one direction for 2 seconds, stops for 2 seconds, spins the other direction for 2 seconds, and then stops and then repeats that. So it'd be a little bit less stress on my motor. So it stops, then spins the other direction, stops, spins the other direction. The other thing I want to mention about the enable pin is that if this was just a digital output, because in this case I'm only setting that enable pin to high or low, I'm only be able to do full speed in one direction or full speed in the other direction or stopped. But I can actually switch this enable pin. Instead of doing digital rates to this enable pin, what it allows me to do is do an analog rate. So we know that the full value, if I wanted to just keep it at the full RPMs, I could simply set it to 255. So in this case, what I'm going to do, I'm going to be spinning the motor counterclockwise full speed. So you can see in this case, I'm just doing one set of rates, but you can see I get the same result. So I get just over 9,000 negative RPM. So it's spinning in full speed counterclockwise. The nice thing is if I'm using analog rate for that enable pin is that I can actually speed it up or slow it down. So in this case, in either direction, if I wanted to do like a roughly half speed, I'm going to turn it on, but instead of full speed, it should be a theoretical half speed. And what that does is it adjusts the voltage that we're providing the chip to enable that motor. So in sense, by giving it less than 5 volts or roughly half that voltage, it should be spinning the motor at half. So we'll see if that actually gives me half speed. But again, this is theoretical. So you can see it's spinning and then spinning at different rates. So you can see it's spinning at 9,000 and then it's spinning at negative 4,600. So it is pretty close to half of that speed. Okay, so that's just showing me how I can control the speed of that motor as well as the direction. So again, by flipping the pin A and pin B from high to low and low to high, that allows it to be either clockwise or counterclockwise. And then by changing enable pin to analog and giving it a value, anywhere from 0 to 255. So if I go down to 0 and I run that again, you'll see that it'll run at 9,000 RPMs to 0 RPM. So if I give it 0 in terms of the voltage, that would be 0 volts. So it's spinning not at all in this case. Okay. In theory, any value between above 0 should spin that motor. But you will notice if you're doing this example, it says it's about 300 RPMs or negative 300 RPMs. In theory, it's showing me that it is working in the simulator, but what you'll notice is that if you're doing this on a real breadboard with a real DC motor, if you give too low of a value here, you actually won't see that motor quite spinning yet because it doesn't have enough momentum to get started or enough voltage to kind of get that motor started from stop. Now, if I was going back and forth between a high speed and a lower speed, it may keep enough of the momentum in the motor to see that difference. So hopefully this helps you understand how we're going to use that DC motor and control it in both directions and also be able to control the speeds as needed.